Very good day to Dr. Sri. Today we are from Group 5 Team 1 and we are here to present our research article, Snorkel, Rapid Training Data Creation with Weak Supervision. So basically what is Snorkel? What does this article talk about? It provides a framework for users to write labeling functions which can be combined to label large amounts of data, and then the system can then learn from these weakly labeled data to create a more accurate model. Let's have a look at our three problem statements. One of it is talking about the traditional methods of manually labeling data, which is time consuming and costly. Second one can be how can we upskill the level of processing the labeling training data with big supervision to later on carry on and understand how to handle large data sets. And the last one would be how we can make machine learning models a bit more robust and strong to withstand the challenges that you may face. So talking about the three objectives of this research, in terms of time consumption, Snorkel can create training data much faster than manual annotation, and it can generate high quality training data. In terms of scalability, it can address the issue of scalability by proposing the parallelization of labeling processes, where this can be done by dividing the input data into smaller batches and labeling them in parallel using multiple processes. In terms of robustness, the objective can be to integrate the robustity by enabling users to integrate multiple labeling functions, and each can be with different types of weak supervision. Next, we can see the overview of the Snorkel system, and it has three theoretical functions that we want to talk about. One of it would be the users can express weak supervision sources like distance supervision, patterns, and heuristics. Another one can be system applies labeling functions over unlabeled data and learns a generative model. And the last one would be this Snorkel system can use the labels to train a discriminative classification model such as deep neural network. I now pass it on to my teammate for his side of the presentation.
So what are those modeling optimizers? How to choose between them? Weighted majority vote is choosing the best label metrics from all labeling methods. Generative model is an optimizer that searches for correlation between label matrices from all labeling methods to denoise them. To choose between this optimizer, calculate labeling density, the mean number of non-extension labels per data point. If the density is in mid-range, choose the generative model. Otherwise, unweighted majority vote as shown in the first figure. In generative model, another question arises when choosing the number of correlations between the solution labels. Using ARBO methods as shown in figure 2, you may optimize the correlation threshold. The dataset used in this research are scientific articles, electronic health records, chemical disease relation, and also spouse signal media dataset. This table compares the accuracy of conventional data labeling methods, output from generative model and output from discriminative model after using probabilistic labels from the generative model. It is clear that there is improvement in 112% to 351% in a range of 2.7 to 42 F1 score. So next slide. Other significant findings reported from the author are 2.8 times faster model building speed, 45.5% increase of predictive performance, 1.8 times faster pipeline execution speed, and 132% increase in real-life predictive performance. The main reasons behind these improvements are utilization of proposed optimizer and gradient descent in conventional model training. So next slide. So as a conclusion, Snorkel can label a continuous stream of large data and save cost and training time. However, for limitation, Snorkel is prone to error and noisy signals when provided data is too small in volume. Generalization error occurs, and this can be solved by feeding large enough data. Secondly, Snorkel at most time require domain expert for better design and better implementation. Non-experts of rules behind this domain place and disadvantage. Future work for Snorkel is to improve accuracy when generalization error could occur. It looks for handling more complicated tasks from various domains too. One of the mentioned real-world application of Snorkel is in healthcare industries, where the predicted labels from Snorkel can find utility in personalized medicine applications. So that's all about Snorkel project. So thank you.